Scenario number 2. What if they're both unfavorable? What if you've got an endothermic process in which you're losing chaos? When would something like that happen? Oh, say photosynthesis. You may remember from biology. 6 CO2 gas plus 6 H2O liquid plus some energy, 2804 kilojoules, goes to C6H12O6 solid and 6 oxygens. So carbon dioxide and water will give you glucose and oxygen, and the energy is on the left-hand side of the equation, so that is an endothermic process. That's not very favorable. If I look at my phases, on the reactant side I've got gas and liquid. On the product side I've got gas and solid. Well, the gases would kind of be a wash. 6 moles of gas here, 6 moles of gas there. But solid is a lot more ordered than liquid. It looks to me like I was more random when I started and I'm less random when I finished. I'm losing my entropy. That's a negative delta S. That's unfavorable. So I've got unfavorable for both. Well, how does that work out mathematically? Girls have true sensitivity, guys have no true sensitivity. Delta H we said was a positive value. T is always positive, and delta S was a negative value. Here's a positive value minus positive times negative. Positive times negative gives you a negative number. So I've got a positive number minus a negative number. Something like, I don't know, 5 minus negative 2, for example. That would be the same thing as 5 plus 2. That would be 7. No matter what I do, my positive value is only going to increase. Delta G is always going to be positive. Delta G tells you if it's always positive, that reaction is never spontaneous. You have no driving forces. That possibility is not going to happen unless you continuously put energy into the system. So when you've got both enthalpy changes and entropy changes unfavorable, the reaction is never spontaneous, and it'll stop as soon as you stop putting energy into the system. So if you have no sunlight, you have no photosynthesis going on. It's not that you can't make that reaction occur, but you have to continuously put energy into it in order for that to happen. Next scenario, please.